Okay, so we have been working on solving equations, working backwards or using inverse operations to be able to get a variable by itself and then discover what it is. Two-step equations is the exact same thing. It's no different, except there's one more little step that you have to do, all right? We talked about that yesterday. The Math Dude video showed you how to take care of two steps. Usually you want to take care of the equation or the number that's being added or subtracted first, all right? But what's the advice that we can have for solving two-step equations? Okay, read this with me. After 2, 1, 2. To solve two-step equations, undo each operation in reverse order, okay? So if you look on page 122, we're going to take a look at example 1. And there's two methods they show for helping you to solve a two-step equation. I want you to look at method 2 first. Method 2, which is the bottom one, which says using symbols, all right? Using symbols. So we're on page 122, and we're using symbols. All right. Here is the equation we're trying to solve. It's 2x plus 3 equals 7. All right. Now, when we were solving one-step equations, it would have probably just said 2x equals 7, and there would not have been the plus 3. Okay. So someone tell me, what do you think we're going to do first? All right. What are we going to do first? Who wants to be brave and let me know? Bianca, what do you think? Bianca says to subtract 3 on both sides, and that is correct. Okay. So we are going to subtract 3 on both sides. Remember, we're doing the opposite operation, and we have to do it on both sides to keep the equation equal. Once we have done that, the adding 3 and the subtracting 3 will cancel out. We are left with 2x equals 4. Now I have 2x equals 4. Who can let me know what the next step is? Devin. Okay, very good. Devin says to divide by 2 on both sides. In fact, if we look right here, this is multiplication. 2x means 2 times x. So the opposite of multiplication is division. We're going to divide by 2. We have to divide by 2 on both sides. This will cancel out and leave me with x. 4 divided by 2 is in fact 2, and that will be your answer. X equals 2. Now, am I finished? Am I finished? Dallas, what do I need to do? Very good, Dallas. She said to check the answer. So I'm going to take this 2, and I'm going to put it all the way back into my original equation. All right? And I'm just going to write this out. I'm going to write out 2, and instead of x now, I'm going to include the 2 that we discovered as our answer. So 2 times 2 plus 3. And that should equal the 7 on the other side of the equation. So 2 times 2 is 4. 4 plus 3 is 7. So we can know that we did our answer correct. Always make sure you check your answer in math. Okay, any questions with that example? Okay, we're going to do one more, and then we'll show you how to solve it using algebra tiles. I don't know if anyone has ever used algebra tiles before. All right, let me make that a little smaller. All right, we have 5y plus 1 equals 26. Tell your neighbor real quick what's the first thing you're going to do. Go. All right, who wants to be brave? Emily, tell me what you said. All right, so we're going to take care of the addition. Very good. What's the opposite of addition, Trey? So what you going to do first, Trey? Very good. Trey said to subtract 1 on both sides. Okay. We know that this will cancel out and leave me with just 5y. 26 minus 1 is what? 25. Very good. And then most of you can probably recognize what to do next. Who wants to tell me? Kaylee? Oh, either Kaylee. Who wants to go first? I think you should do rock, paper, scissors to see who's going to go first. All right, here we go. Rock, paper, scissors. All right. Kaylee, you won. So what are you going to do next? Very good. Tell me, why are we dividing by 5, Kaylee? Dividing would be the opposite of what? Very good. And right here, the 5 right next to the y, 5 is our coefficient. We know that means multiplication, so we're going to divide by 5, and then I get y equals 5. Once again, put it back in. This one's kind of easy to do, right? Because we can do 5 times 5 is 25, plus 1 is 26. We know that we got it correct. All right, so that is the method using symbols, okay? This would be the most common way that you're going to do it, all right? Now, some people, it really helps them to see this like using a model, something called algebra tiles. So I'm going to show that to you now, okay? So this is something we set up, and we're going to use algebra tiles to set up an equation. So what's cool is I've set these up. These are called infinitely cloned, right? So you can just keep pulling them off of here, and they'll come forever, okay? So we're going to set up this equation. Let me get rid of that. What do I have on the left side of the equation? We're looking at the same equation, 2x plus 3 equals 7. So what am I going to have on the left side of the equation? I need 2 x's, right? All right, so that's 2 of these. So I got 2 x's. What else do I have on that side of the equation? I got 3, right? So I need 1, 2, and 3. And what do I have on the other side of the equation? Just 7, okay? So sometimes it can take a while. 1, 2, 3, 4, 5, 6, 7, okay? All right. When we're using algebra tiles, we simply look at them and try to divide. We want to get those x's by themselves, same thing. So the first thing, if I want to get these x's by themselves, I got to get rid of these 3 1s, right? So I'm going to take care of those 3 1s right away. Boom, gone. If I took away 3 1s on this side, what do I have to do on the other side? I got to take away 3 1s. All right, so let me take away these 3. Gone. All right, now I want to get the x by itself. All right, so I'm going to split these up. All right, so I've got 1x there, 1x there. If I split this in half, guess what I have to do over here? Split that in half, so there's 4 of them. So I put 2 up there and 2 down there. So each x is equal to what? Each x is equal to 2, which, if you'll remember, is the same answer you got using the other method. Okay? All right, so if that's helpful to you, you can draw or use anything to represent algebra tiles to help you manipulate that. Okay. Do we need another example of algebra tiles, or do we want to move on and try the got it? Take a vote. Who wants another algebra tile example? Okay, one more? All right, let's do one more. So we're going to do that other example, which was 5y. Now, 5y, we can still use any variable, right? So they say y, but I'm just going to keep the x's. So I need 5 of these. All right, I have a feeling this one's going to take a while. Plus 1, right? Let's see, here. And now I need, oh my goodness, 26. So let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 25, 26. I think that's right. That's a lot. Okay, not a good example for algebra tiles, but it still works. Now, what's the first thing I'm going to do? I want to get these x's all split up, okay, individually. So what do I have to get rid of first? Jamie. The 1. Very good. So I got to get rid of this 1. If I get rid of 1 on this side, I have to get rid of 1 on this side. Very good. Now, I just kind of want to split all these up and get the x's by themselves. All right? So I kind of already had them in groups. So if I split these into 5 groups, I'm just going to do it this way to show it. All right, there's 1 group, 2, 3, 4, 5 different groups. And each group has how many in it? 5. So each x is worth 5. And you'll understand that that is the same answer we got when we solved it just using the numbers. Okay? So if this is helpful to see it this way, to visualize it this way, great. I always try to give a couple different ways because everybody learns in a different style. All right, what I'd like you to do now is I would like you to do the got it problems at the bottom of the page. Got it A and got it B. Go ahead and get busy on those.